What's up, everyone? Welcome back. Patrick here. Moving on to the next question, the next word problem, still dealing with quadratic equations. So we're told the formula for the sum of the first n even natural numbers is a quadratic relation. And in part A, we have to verify it's a quadratic relation and then factor it if possible. Then in part B, we have to use the formula to find the sum of the first 10 even natural numbers. And then in part C, if the sum of the first n even natural numbers is 1056, we have to find the value of n. So we're actually not going to be using equations all the way to part C. With part A and part B, we have to first figure out what the actual, well, first we have to verify it's a quadratic relation. We're going to do that with first differences, and we got to find the formula. And then we have to use the formula to find a certain sum, the first 10 even natural numbers, the sum of the first 10 even natural numbers. And then finally in part C, we'll set up the formula as an equation and then solve for n. So parts A and B, it's more so, we've done questions, very similar questions like this before. So it's more so going to be a review, but it's a fairly complex question. There's a lot going on. So a review, I feel like, won't hurt too bad. So remember, what are natural numbers? Basically, it's all of the positive integers, 1, 2, 3, etc. But we're dealing with the even natural numbers. So that would be what? 2, 4, 6, 8, 10, etc., etc. Basically, all of the positive even integers. And so what we're doing is we're finding the sum of them. So what n represents here, this column, represents the number of these even numbers that we're dealing with. Okay, and then this, let's let s be the sum of them. So what's the sum of the first natural number going to be? Well, the first natural number is just 2, and the sum of that is just going to be 2. What's the sum of the first 2 even natural numbers going to be? 2 plus 4, which gives us 6. What's the sum of the first 3 even natural numbers going to be? 2 plus 4 plus 6, which would be 12. And then the sum of the first 4 would be 2 plus 4 plus 6, which is 12, plus 8, which would give us 20. And then the sum of the first 5 would be basically the sum of all of these, which would be what? 30? You could just also take the 20, which is the sum of the first 4, and then add the 10, which would give you 30. Right, and it keeps going like this, and basically what we want to do is find out what's the formula going to be for the sum of the first n even natural numbers. What's this general expression here going to be? Well, we got to verify that it's actually going to be a quadratic expression. And the way we could do that, if you remember, is with first differences. So it's like we're given a table over here. This is the independent variable. This is the dependent variable. And so remember, first differences, we would do 6 minus 2, which would give us 4. 12 minus 6, which would give us 6. 20 minus 12, which would give us 8. And then this would be 10. And then we take the second differences, and notice that when we take the second differences, remember we do bottom minus the top, we'd have 2, 2, 2, because the second differences are constant. It means that we are dealing with a quadratic relation over here. If the first differences were constant, then it would be a linear relation. This is a quadratic relation because the second differences are constant. So we've done questions like this. If you need a review, you could go back to the previous chapter when we first started talking about quadratics and how to recognize that something is a quadratic from a table of values like this. So the first challenge is actually understanding what we're dealing with, the sum of the first n even natural numbers, and setting up the actual table, and then taking the table, finding the differences, realizing the second differences are constant, meaning that verifies that this is a quadratic relation. that we're dealing with. Okay, so that's the first step. That's how we verify it. Now we have to find the actual formula, because we're going to be using the formula. We're going to be using the relation in parts B and C. So how do we do that? Well, notice that these are basically coordinates, right? So we know if we create just a general, we know we're dealing with a quadratic. So if we create a general expression, it's basically going to be s equals an squared plus bn plus c, like that. You could also use x and y here if you feel more comfortable, if you don't want to introduce new variables. I'm just using n and s just because they intuitively make sense. Here we said the first n even natural numbers, so it makes sense to create this column as n, and then s represents the sum. So that's why I use the letter s. But again, you can use whatever variables you want here. So we know it's going to be a quadratic. It's going to be in this kind of format. The question is, what is the actual quadratic going to be? We have to find the a, b, and c value. And how can we do that? Well, we can use 3 points. So notice that this point here, it's 1 and 2. So if we put in coordinate form, we got 1 and 2. This is going to be 2 and 6. This here is going to be 3 and 12. And so if we have 3 unknowns to solve for, we could use 3 points. And so plugging in the first point, we would plug in 1 for the n values and then 2 for the s values. So we'd end up with 2 equaling 1 to the power of 1 is just 1. So that would be a plus b times 1, which is b plus c. So we end up with that first equation like that. That comes from the first point. Then from the second point, we would plug in 6 for s, so we'd have 6 equals, then we'd have 2 to the power 2, which is 4 times a, so it'd be 4a plus 2b plus c. That would be the second equation. Then if we do the same thing with this point, plug in 12 for s, so we'd have 12 equals, then we'd have 3 to the power 2, which is 9 times a, so it'd be 9a plus 3b plus c. Like that, right? So now we got 3 equations and 3 unknowns to solve for. So multiple ways we can do this. Let's, what I'll do is I'll actually isolate for the, let me think of how to set this up. I'm going to isolate for the c value with this first equation here. So let me erase this. Let me take that equation. I'm going to isolate for the c value, so I'm going to bring the a and the b over, so I'll have 2 minus a minus b is equal to c. And then I'm going to take this expression and plug it in for this c value and this c value. So then what would happen is we would end up with 2 equations and only 2 unknowns. So notice that if I take this, plug it in for this c, let's do this up here. So we'll have 6 equals 4a plus 2b, and then plugging in this, we'll have plus 2 minus a minus b. Right, so we have 4a plus 2b plus c, but I'm plugging in this for the c value over here. And now notice that we got rid of the c's and we just have everything in terms of a and b. And so we can simplify this. I'm going to bring the 2 over. 6 minus 2 gives us 4. Then we'll have 4a minus a, which would give us 3a. And then we'll have 2b minus b, which would give us b, like that. So now we have this new equation. And then I'm going to do the same thing with this over here. So we'd end up with 12 equals 9a plus 3b, and then I'm going to plug in this for this c value. So we'd end up with 2 minus a minus b, like that. Right, and then bring the 2 over. 12 minus 2 would give us 10. 9a minus a would give us 8a. And then 3b minus b would give us 2b. Like that. And then we could further simplify this. We could actually divide both sides by 2, divide everything by 2. Here we couldn't do that because the 3 is not an even number, and then the b was already by itself, but over here, everything can divide by 2, so we'd end up with 5 equals 4a plus b. Now, you may go about this, by the way, in a different way, solving for the a, b, and c. Whichever way you go about it, just make sure that you're getting the same solutions that I'm going to get. So now notice what we did. So as a quick recap, we isolated for the c here. Then we plugged in that expression here and here in order to get 2 new equations with only 2 unknowns. And now we could solve for the a and the b. So let me write those up here. So we'll have 4 equals 3a plus b. There's one equation. And then this equation I'll write over here. 5 equals 4a plus b. Like that. So from here, what we can do is, let's isolate for this b, so I'll bring the 3a over. I'll have 4 minus 3a is equal to b. Then I'll take this, plug it in for this b. So we'll end up with 5 equaling 4a plus, instead of the b, I'm going to write the 4 minus the 3a. Like that. Bring the 4 over. 5 minus 4 gives us 1. 4a minus 3a just gives us a. And so a is equal to 1. We get the a value. And then if we want to get the corresponding b value, we could plug it into either of these. I'll plug it in here since the b is isolated. So if I plug in 1 for a, I'll end up with 4 minus 3 times 1 is equal to the b value. 4 minus 3 would give us also a b value of 1. And then if I want to get the corresponding c value, I could take this a and this b and plug it in for either of these over here and then solve for c. Here the c is actually already isolated from this first equation. So if we plug in 1 for a and b, we'll have 2 minus 1 minus 1. That would give us the c value. C value would actually just be 0. You could take this a value of 1, this b value of 1, plug it in either of these and solve for the c value. Whichever one you use, you'd end up with a c value of 0. And those are the solutions. A is 1, b is 1, the c value is 0. So whichever way you go about it in terms of solving for the a, b, and c, make sure that you're getting those same solutions. And so now coming back to our general expression, the c value is just 0. That goes to 0. And then we plug in a is 1, b is 1. So we end up with s equaling n squared plus n. That is the formula right there for the sum of the first n even natural numbers. This is the formula right here. And you could verify this. You could take this and test it with these values that we got, just manually listing out the even natural numbers and then finding the sum of them as we went along down the table. You could test this with these. So if I plug in 1 for n, 1 squared plus 1 gives us 2. What if I plug in 2 for n? 2 to the power 2 is 4, plus 2 gives us 6. What if I plug in 3? 3 to the power 2 plus 3 gives us 12. 4 to the power 2 plus 4 gives us 20, etc., etc. So notice how this formula is working out with this table, with this corresponding table. So we could be pretty confident that this formula here is correct. And now we can easily go into solving parts B and C. So in part B, what they're asking for is what's the sum going to be of the first 10 even natural numbers. So instead of writing out the first 10 even natural numbers and then adding them up, right, we're trying to figure out what is this value going to be once we have a 10 over here. Well, we could just plug it in here. So we'll have S equals 10 to the power 2 plus 10, which would give us 100 plus 10, which would give us 110, like that. Okay, so if you were to take the first, you could test it out if you have the time. If you were to list out the first 10 even natural numbers and then add them all up, they would all add up to 110. Right? That's another way that you could maybe test out the formula if you want. I'm not going to do that. It's going to take quite a while, but if you do have the time, you can just keep writing them out, like 12, 14, 16, 18, etc., etc. Add all those numbers up, the first 10 of them, you'll end up with 110. So that's the answer to part B. And then part C, they're saying the sum of the first n natural numbers is 1,056, and we have to solve for n. So in this case, we're given the sum. So we'll have 1,056 equals n squared plus n, and we have to solve for n. So this is where the quadratic equation comes in. Notice that it's an equation now to solve. And the way we do that is we bring the 1,056 over. That'll become minus 1,056, and then we'll have a 0 right here. And so we have to solve that. This here we could factor, so notice that the a value is 1, the b value is 1, the c value is negative 1,056. AC would be negative 1,056. What two numbers multiply to negative 1,056 and then add up to that b value of 1? It would be 33 and negative 32. 33 and negative 32. Okay, 33 times negative 32 would give us negative 1,056. 33 plus negative 32 would give us positive 1. So we could take this, decompose. I'm kind of going through all of the steps here. Again, you don't have to necessarily if you don't want to, but I'm just doing so. So if we take out the n from these two, we got n plus 33. From these two, we could take out a minus 32, and we'd be left with n plus 33 as well. Then we could take out an n plus 33, and we're left with an n minus 32, like that. Okay, so whichever way you go about it, this quadratic here on the right side, it factors into those two brackets. So, writing that down over here, we end up with that like this. Okay, and so from here, we have to find out when do those factors equal 0. This is happening when n is negative 33, and this is happening when n is 32. But remember, what is n? N is the number, the first n even natural numbers. Well, can't have a negative value. That wouldn't make sense, right? So the answer ends up being 32, meaning that the sum of the first 32 even natural numbers is 1,056. So if we continued this pattern, here we only have 5 of them listed out. But if we continue this pattern, again, 12, 14, 16, and we listed out 32 of the first even natural numbers, and then we added all of them up, we'd end up with 1,056. But again, we don't have to do it manually because we found this formula in part A. So we were able to take the 1,056, plug it in for S, and then we just solve this quadratic equation like we've been solving throughout the section. We get two values, ignore the negative, we have an n value of 32.